Hi, good morning everyone. My name is Abhishek and this is my project real-time carbon monoxide based smart ventilation system for enclosed car parks. Main controller of the system is ESP32 microcontroller which processes all the sensor data, and my MQ-7 sensor which is the carbon monoxide sensor, and DHT22 is the temperature and humidity sensor to monitor the environmental conditions inside the car park. And I'm using 20x4 LCD display. My project provides a smarter solution by operating the ventilation system only when it is actually required. Carbon monoxide is a colorless, odorless and toxic gas produced mainly by vehicle exhaust. In enclosed car parks, poor ventilation can cause CO gas to accumulate, creating a health hazard for people. And in a way that we cannot calculate the sensor quantity with the area location. For example, like 10 meter is our car park area, then we cannot assume that okay, two sensors can detect this all 10 meters coverage, which is not feasible. Why? Because sensor is a gas detection sensor, and there are some other restrictions for that. For example, car park layout, ceiling height, airflow, exhaust fan locations, vehicle movement, and enclosed corners. All these are considerable, and then only we can decide that how many numbers of sensors is needed for the specific car park. That's how only we can calculate the number of sensors. And then we can say simply like 250 meter square area can detect can be used around 1 to 2 sensors. The actual project is designed to detect carbon monoxide gas. However, it is not possible in the indoor and demonstrations. So here carbon monoxide is unsafe because of the toxic gas. Therefore, for our demonstration, I am using a lighter gas as a substitute to trigger the MQ-7 sensor. The sensor response will activate the relay operation, and then the buzzer and automatic fan will be controlled through the relay without exposing any hazardous carbon monoxide gas. With the help of lighter, we are triggering our relay and both of the fan and buzzer. In actual scenario, MQ-7 sensor is capable of detecting carbon monoxide concentration in the approximate range of 20 ppm to 2000 ppm after proper calibration. That ESP32 is supported with Wi-Fi access point, so it is easier also to connect. Wi-Fi features allow maintenance personnel to monitor the system remotely. With the project demonstrations how IoT technology can improve safety and energy efficiency in enclosed car parks. By continuous monitoring carbon monoxide, temperature, humidity, the system automatically controls the ventilation fan and provides remote monitoring through web interface. All through this prototype uses a MQ-7 sensor for educational purpose. The same system architecture can be upgraded with industrial grade sensors for real world commercial deployments. Thank you.